I'm going to start by introducing Saul as a past pupil of Advantage Learns, but also a past pupil at Yeshiva College, I believe, actually. And Saul was in Advantage Learns further studies programs, specifically further studies physics, and he graduated grade 12 last year, and so obviously graduated with us last year, 2023. During both his time at school and his time at Advantage Learn, Saul has been on a mission to solve problems and do that in a creative way. And so a lot of you guys are big-brained individuals. And so this is going to be a really nice moment for you to hear from someone who's used the skills and the talents that he has to make a difference. And how can you do the same is kind of the key question. How can you do the same? Because we all have potential to make that difference and to make that step. So without further ado, Saul, I'm going to hand over to you to take over the presentation.
Thank you. Hello, lots of people. I feel really privileged to come and speak here. I quite like what I do, and I think it's quite fun, and I hope like sharing it with people. So hopefully you guys enjoy too. So first question is, who is me? Hi, I'm Saul. I'm 19. I matriculated last year at IUB Matric. I did AP Physics through Advantage Learn. I was the head of my school's Environment and Advocacy Committee, and I'm the founder of HandPrintSA. One of these things is a little not like the others, but anyway. So this all started not last year, Jesus, 2 years ago. It started in 2022, where I was working on a program. I needed a prize, and someone had sponsored an Ender 3v2 3D printer. It's this one on the right, for my school. And being a bit of a techie, I was given access to it and allowed to use it. And I was looking for something I could print as a prize, and I found this thing on the left. These are finger extensions. They're meant to be a kind of dress up accessory, and thought they were cool. I decided to print one, and then I had a bit of a thought. If I can take my fingers in this model and make them longer, somewhat controllable fingers, then could I find someone without fingers, use this model, and then give them fingers? Was that at all a possibility? And so I went online, did some looking, and I found Enable. They are a awesome community of about 40,000 volunteers with these open source designs for Alum prosthetics that can be 3D printed by almost anyone. And they do some really awesome stuff. They've got a bunch of designs and guides on how to use them. And I decided, oh, this is awesome. Maybe, part of advocacy, I could use this and try and partner with them. So this is their map of their presence of what they call chapters. And you'll notice a bit of a problem here. There's no one there south of Ethiopia. There was no Enable presence here. And I found that weird. We have a really good need for this kind of thing in this country. People in prosthetics can cost, for a body-powered prosthetic, 60,000 Rand each. And that's a lot of money, whether or not you have help, medical aid. I think it was 71 to 79% of the population doesn't have medical aid. And the government waiting lists are 6 to 10 years. So maybe if you wait a decade, you might get one, maybe, but the likelihood is low. And I was wondering, we really have the need for it here. We really have an opportunity. Saw the need, I decided to try and fill it. That's about all I did. So we had then the first attempt at making one of these. You can see here is called the Phoenix V3 hand. Also a bit next to me here for scale. This is quite a small hand. It would be for a 4 to 7-year-old child. For someone who didn't have fingers, this would give them ability to pick things up and use them. And I decided, I'll give it a shot. I got a friend who had a printer. I asked him if he'd print it. He said yes. Got everything together, put this together, and then was like, Okay, well, it works. And that's a problem because now I have to actually go through with this. And I had some problems. The first being I was 17, I know nothing, I'm not good at anything. I could do stuff. The second was that I'm in school and busy and exams and homework, and how am I going to fit all this in? And then the next three were kind of a bit bigger, which was that I don't know if this works. I can't trust what I see online just because it says this will work doesn't mean it will. I have no access to a patient. No, I don't know anyone who doesn't have fingers or doesn't have a hand. And even if I did, why would they trust me? A hand is quite an expectation. Why would they trust me that, yeah, this 17-year-old can give me a 60,000 Rand device for free? Sounds like a scam. So this is now the fluffy part. This is really the message I have for people. I'm not special. I have ADHD. I can't sit still. I have tremors, which for putting small pins in places and such isn't a very good thing. I'm not a special. I don't know anything more than other people. I just took the opportunity I saw and I didn't give up. Each problem is you've got to treat it like a question on a test. You don't give up the test because of the one question, even if you don't know the answer, especially when you don't know the answer. You just find an answer, and then you move on. And if it takes a while, that's okay. You just got to watch the clock in school. Real life, that happens less. I'm not going to say it doesn't happen, but that happens. So fluffy part done. Getting down, I'm quite an engineering brain, so getting down to practical stuff. Problem one was I'm 17, I know nothing. Well, other people do. So I asked around. I got my father's help. He helped a huge amount in essentially everything. My sister became the art department. You can see her lovely art there on the bottom. Finding other people to help. My friend who had the printer, uh, other people who know things or can help you is one of the best resources you have. And it's something you don't usually use until you need to. And it's something you can really exploit. Number two, I'm in school. I don't have time for this. So the solution is destroy my sleep schedule. Just don't sleep. That no problems with that. I don't recommend that. Don't do it. I did it. It wasn't good. Don't do it. But it is what I did. In addition to trying to maximize my time, I'm sure any past students that are here see that book, possibly still current students see that book on the left and get trauma. But I was walking around clinics, talking to doctors, and sitting in waiting rooms studying poetry out of this book. I went to meetings with it. I would, in the car, on the way to places, I would be studying. It's just about maximizing your time. You don't need more time. You just need to use the time you have because you can't really get more time. Problem three, will this work? I don't know. So who does? Well, again, you ask around. I asked some doctors, an orthopedic surgeon, Dr. Bradley Rabin, Vanthia Pavli, you can see here, helped us a lot. And I spoke to a lecturer from Wits, Mr. Tahira Mangera, who then led me to Michael. Michael's kind of the answer to every problem. This is Michael. Michael also answered problem 4 and 5 of having no access to patients and not being trusted. As you can see, Michael himself is a double amputee, one below the knee, one above the knee. And Michael runs Jumping Kids. Jumping Kids is a nonprofit. It helps kids who don't have legs and gives them legs. It's part of Us Express, which are a prosthetic import company in South Africa. And last I checked, they'd helped over 250 kids get legs again, including one who I believe is this guy on the left, who is now a Paralympic athlete and gold medalist. They do some amazing things, and to see how Michael would interact with people and such was really awesome. And Michael also introduced me to one of the most magical places I know of, the Hope School. The school, as soon as I walked in, one of the first things I saw was two different people helping each other with things they couldn't do. One person couldn't hold their bags, one person couldn't walk. So the one person pushed the other in the person's wheelchair, and the person in the wheelchair was holding both bags. And that kind of idea of helping each other out to doing what you can and someone else doing what they can and together doing whatever you need to was kind of a way I changed my outlook on almost everything. And it was this most magical place that still every time I visit, it's awesome. So then we got going. So I got help from my friend again, used his printer, and we printed this arm for Owetu. This young man on the right is Owetu. He is 13, and for the first time in 4 years, he could pick something up and drink from a cup and eat for himself. Literally the first time in 4 years. And as you can see from his smile, he was quite happy with it. And it was the most amazing feeling when I gave it to him. And everything was going good. It was all great. It looked awesome. And then, as you can see in the video, it broke. And that wasn't easy. And I couldn't keep asking my friend to use this printer. And I wanted this to become more than just a side project. So I found a corporate sponsor, and I got one of these, an Ender 5 Plus, and I got to work. And so we made two new devices. We fixed Owetu's arm. You can see him there drinking. And we gave an arm to this guy, Uchle. He's in grade 6. And this was, for Uchle, this was the first time in his life that he could ever eat something for himself, drink something for himself. And it was really amazing to see. The challenge with prosthetics is it has to be custom. Despite the fact that, you can't make a new design for every person, it needs to be custom fit to every person to a quite large degree. It needs to be the right size. It needs to fit, be comfortable. And that's the big challenge with prosthetics is how do you do that? And so part of why they're so expensive. So why could I do this any better than anyone else? It's because I have a 3D printer. And the magic of 3D printing is I can print one thing 10,000 times, just like a injection mold can. But the thing an injection molds can't do is I can print 10,000 things once each, and it costs me no more than doing one thing 10,000 times. And as a result, I can edit every single device and custom fit it, and that's no difficulty to me. And so we started doing that. You can see Ulrich quite happy with his. And so you might ask, what are these devices? Full clarification, I did not design any of this. These are all designs from Enable, and they're really awesome. But I don't think I'm a genius. I can't this. I'm not that good. So these are the devices. There's a couple of different devices. All of them are going to work through what's called body-powered actuation. So the person's going to close the fingers by either bending their wrist or their elbow, and that's going to then allow them to grab something as well as move their arm. And they are all these are all made of plastic and a few other pieces here and there. So our first device that we have is called the Phoenix Hand. It's what this is. And there are 5 parts of this that I don't print. Only 5, which for a thing that that is a full prosthetic was quite awesome to me. So those 5 parts are, there's 3 bolts, some catgut line, dental elastics, strap, and fingertip grips. That was all I couldn't print. And the way this works is, so if you imagine I didn't have fingers, so my palm would fit into here, little hole over there, okay? And this would strap onto my wrist. And as I bent my wrist, my fingers would close. And then they snap back open due to the dental elastics over here. And the way it's working is that the path that these wires have to travel is being increased when you bend, and they're hooked back up into the fingers. And that's it. It's that simple. That's all you need. And so that was the first design we did. But the first patient needed an arm, an Elfie arm, just one of these. The Elfie, this one is a demo one, it fits me. Also, my sister, well done on the art. It's beautiful. And this one instead works by elbow. So instead of your wrist, there's your elbow, and that's because this is for someone who's lost from here down, or essentially here down. It's for someone who doesn't have the palm space to push on the palm of this. So we just use the elbow. And this can extend. There's also a shoulder. And and you also go down to fingers. So these two were the kind of the first two models, but now there's a new improved model. This one's looks a lot better. It's a lot more fitting to different people. It's easier to print. Almost everything about it's better. This is called the kinetic hand. Currently putting one together down there, but it's not yet together. And there are only two parts to this that are not printed. There is the screws and the straps. Everything else is printed because someone came out with a flexible material you can print in called TPR or TPU, and you can then use that as hinges. You use it as what's called the tensioners, as well as the palm, and the fingertip grips are all now made of TPU and therefore printed. So what is printing? What do I mean by printing? I don't mean an Epson. I mean a Creality or a Bambu Labs, something called FDM 3D printing or fused deposition modeling. The way it works, you can imagine it as if you did take an Epson, a normal printer, and what you did is you took something, almost anything, you cut it up into 1 millimeter slices, and then you took a picture of each slice, and then you printed that on 1 millimeter thick paper, and then you cut it out, and then you layer them up. Eventually, you'll have something that's the same shape. So I do the same thing with my printers, except they use plastic. Starts out looking like this. This roll of wire-like plastic. This is called PLA. And you layer it and layer it and layer it. You put it through a nozzle, which it's about 200 to 300 degrees, melts it, and then puts it down on a little CNC machine and makes things. Now, what you can see on screen is not exactly that. It's the same idea and it works through the same system, but this one uses concrete and prints houses, whereas mine uses plastic and prints prosthetics. You can print in metal, as you can see, concrete, cakes. Yeah, it's almost like icing a cake. It's very similar in how it works. And these things are not that expensive. You can get a Bambu Labs P1P, which is one of our printers that we use, for only 16,000 Rand here. You can get a Ender 3V2 for, I've seen them for 2,500 Rand. And one of the beautiful things that Enable does is anyone, these designs are open source, so anyone, anywhere, at any time that has a printer, you can print one of these. It's not difficult. And put it together and give it to someone who needs it. You don't need to be a major prosthetics company with thousands and thousands of employees and millions of Rand. You can just be a person. And oh, sorry, I forgot. The next step is thermoforming. So when you print these, actually print like this, flat, as you can see on the left. They, because of strength and just how easy it is to print, we print these flat. And then what you do is you take a heat gun or boiling water and you dunk it in the water, and then it becomes moldable and you can bend it around like this. And this also is plays towards the fact that we need to we need to customize every single vase. We need it to fit every person's arm. People have different thickness of arm, and this obviously needs a strip, so it needs to be, it can't be too loose, can't be too tight. And so this is another thing that helps us is thermoform. Kinetic hand doesn't really need it, but most of the vases we do this, and that's all you need. It's printing, assembling, thermoforming. But these are, to design them and to realize when they're needed is not so easy. One example I have is we had a patient, Chotzer. Chotzer had his fingers were cut essentially just before just after his first knuckle, just before the second knuckle. So he had a bit of a stub of a finger, but he could still hold his phone. He could use it. It was a real challenge to me to say, well, what can I give him that he doesn't already have? And so the model we were thinking about is one of these. It's called a Nick's finger, for when you nick off your finger. It just makes the rest of your finger. And what I ended up doing is I gave him a pair of scissors. And after giving him his device, he just sat there with the scissors, opening and closing it for about 5 minutes. He's 18. Just sat there opening and closing the scissors, because that's what he couldn't do before. you don't really realize what you use your hands for until you don't have them to use. Your hands are really interesting and really cool and really good. They have, on each hand, you have 27 bones, 27 joints, 34 muscles, and over 100 ligaments and tendons. Just to do this, just to grab a stick to whack things with. You evolved this over millions of years to be one of the most able things, robots. It's really difficult to do this and then this and this and this and that. To do that is not an easy feat. We can just do it naturally. We don't even have to think about it. You have pressure sensors and texture sensors and temperature sensors and so many different things. How do you make that? How do you make that again? You don't have millions of years. You don't have the powers of evolution. How are you going to do that? And it becomes really difficult, and that's why Enable, I think, exists. You have 40,000 people who are just giving of their time and helping out and designing these things. I mean, if you try and design something like this, you can't have any buttons, you can't have any levers, because people don't usually, when people have lost one hand, often they've lost the other as well. So you can't have a button, you can't have a switch. And every time I was trying to change these designs for the custom designs I needed to do for the one custom device that I had to build, it's every time you see it, it's just like, nope, can't do that. Oh, do this, nope, can't do that. And you start to see the world as a very different place. And something I think in general we should improve is, you think that like our world is accessible to everyone. It isn't. It's really not. Our world is made for interaction with these things. If you don't have them, it's suddenly a huge loss. One of the examples was, if you see on these straps, you've got to thread them through here, and they're just Velcro, and they Velcro on. But if you only have one hand and if you don't have any hands, and one of your arms is going into this, how are you going to do the Velcro up? You can't grab. I didn't know. I couldn't solve this puzzle. I tried and I couldn't. And this grade 6 kid, after one day of having this, had figured out his way of doing it. He, without any hands, threaded these things in faster than I could do it with fingers. Then used his shirt, stuck the Velcro onto his shirt, then held the one side down and pushed it on with his body. Kid's awesomely smart. Could never think that up. He had this huge potential, but he suddenly couldn't use it or utilize it or realize it, because he just didn't have a hand to be able to write properly, and these things would hamper him hugely. He was extremely intelligent. And I realized that that's ultimately the thing that there was to overcome, the problem that there was, that these people have potential, huge potential. And we just don't use it because they are sitting in a line for 10 years waiting to get prosthetic. And so that's what I hope to solve, and what I still hope to solve. And if anyone wants to help, you can get in touch with me at handprintsa@gmail.com. We could use volunteers, we could use outposts elsewhere, we could use just people. If you just want to get involved with Enable and not handprint directly, let me know. I'm happy to get you into it. And if you have a 3D printer, definitely you can do this. It's not hard, I promise. I'm not special, I'm not smart.
Amazing, Saul. I mean, your story is so, so inspirational. Yeah, I feel like my kind of key takeaway from this is we're in an age today where there are so many communities that you can lean on, like Enable. It's not a matter of we don't have the information in front of us. It's a matter of us making a decision to use the information that's in front of us and to seek out that information. And the fact that you've been able to do that so well is amazing, so inspirational. So
Thank you.
we do have some questions. I'm going to start going through them. And guys, if anyone has more questions, please feel free, as I said, to leave them in the chat in the Q&A. So I'm going to start with the first one that came through, and I'll kind of go in order of who sent what. We have an anonymous question that came through, which is, how do you bend fingers? And so maybe we can do that demo again, Saul,
Yeah.
to show them.
So the way it works in general is, you have a little piece of plastic over here that tie one end of a fishing line to. So this is obviously for what are called hand devices. So this is for essentially someone whose hand looks like this. They have no fingers. So you have this line that attaches over here. You've got a pivot here. Turn. This would be strapped onto someone's wrist. Okay. And then they would put their remnant of their palm in there, in there. Don't know what I'm trying to show. It's a hole in
Yeah,
there.
I see.
And they go through these little holes up here, in through the top of here, out into these channels, and then down onto this side where they tie over here. And then, so as the person pushes down on the surface, bends their wrist, it'll close the fingers. And so I, in testing this, had to get quite proficient at grabbing things and holding them and such. And with even so, I'm not so good at it. But a lot of our patients are a lot better at it. With the arms, you actuate it with the elbow instead. So as you bend your elbow, it's bending so that as it comes closer, you can still hold it. And with the fingers, it's movement of the remainder of your finger.
So cool. I love the fact that people have discovered these answers to significant problems in people's worlds. I mean, people who don't have a finger or don't have a hand. Absolutely amazing. Okay, we have another anonymous one. How would you help build a prosthetic, sorry, excuse me, jumping on that word, for someone who has lost their hand from the elbow up?
Okay, so this is called, so in prosthetics terminology, you generally talk about a joint and then below it. So you have below knuckle, below wrist, above wrist, below elbow, above elbow, below shoulder, above shoulder. So if you're talking about, I don't know if this question is talking about a below wrist, sorry, below elbow, above wrist, which is that is exactly what these solve, for mostly above wrist. A below elbow, you only had a small amount left. We would then move to a shoulder device, which that where you would actuate with moving your shoulder. They're fairly uncommon. You have two types. You have ones that you actuate with your shoulder and ones that you push on the fingers and then they just hold. But then you can move the shoulder around, and that will bend the elbow forward and back. Use these different methods because of in different situations, depending on what the person wants out of it, or possibly you give both to one person and they use it as they need. But mostly those would work by attaching something here across your shoulder. So what we always do is you take the nearest joint you have and you attach one thing to above that joint, one thing to below that joint, and then that joint's movement can be used. Obviously,
Okay.
if you lose your shoulder, you can't really do anything. You can only do stuff for balance.
So in the case of this person, they've just clarified. So what they're saying is above the elbow. So essentially you would use the shoulder. The shoulder would be your...
So you'd strap one thing up here, one thing over here, and then that would allow elbow movement, and then you'd have fingers that can just set in place and be
Okay.
moved about. And yeah.
Somebody wants to know, do you only deal with hands or do you deal with the feet as well?
So I have seen some people who do deal with feet, but and there are some designs that do Alum, but there's kind of a big issue there, and it's something Michael has mentioned to me quite a lot. Legs are scary, essentially. Your legs are really strong. They're really structural. If you break, you fall. If a hand breaks, the most is, something that you were holding breaks. If your leg breaks, you fall down the stairs. You hurt yourself. You really hurt yourself. It's a bit more of a danger. So when we're talking about printing in plastic, that's not something we wanted to even try and attempt. Some people have, but it's not yet matured or strong enough to really be reliable. And Michael was very much in agreement with that. You don't want to use plastic or something that, this plastic, if you leave it in your car on a hot day, it can start weakening and deforming. You don't want to have to deal with that when you're talking about what you're standing on. When you're talking about an arm, you can. However, leg prosthetics that have as you saw Michael's, they're mainly just, a bar of metal. They don't look particularly pretty. What we can do is attach aesthetic pieces to that made of plastic. That is somewhere where it is being used more, as well as for feet and the soles of the feet. It can be quite useful. Obviously, this only being in normal feet as opposed to blades. But we do hope to use a metal 3D printer to hope to possibly actually move to legs if that ended up being viable.
Amazing. So cool. Okay. Jemiah wants to know, good evening. Are there people with prosthetics, or are people with prosthetics able to communicate in sign language?
So not with our hands or arms. Our fingers, feasibly, they could. I did at one time try to learn a bit of sign language, but I don't really know much. I never managed to complete learning it. Uh, Finger control is a very difficult problem. When you only have one input, one motion to actuate, it's hard to make different outputs. Essentially, what you need is you need now another input, right? You need more keys on your keyboard. And because you don't want to use buttons, you don't want to use levers or switches, that becomes quite a difficulty. There are a good couple of design ideas and uh, prototypes that are trying to do this, but it's a problem that's been going for long. I've got some of my own designs of ways to attack the problem. Um, but so individual finger control when you only have your wrist, quite difficult. And on body powered devices, it's essentially, unfortunately, near impossible. We're never able to live up to having a hand again. Like I said, insanely complex device. It's hundreds of millions of years of evolution. That's really awesome. We can't really compete. What we can do is restore the more basic functionality of holding and moving, essentially. What I want to add to that is,
Yes,
in
go
terms
for
of
it.
what I do, yeah, absolutely contact me. I'll let you know everything. In terms of like the cause I'm doing for of making a better world for everyone, I don't know. You do. You're the one who knows. You're the
Yeah.
one who comes up with the idea and says, oh, there's this thing. I could fix that. I think I could do something about that. Just look around you and find an opportunity and don't be scared to take it. That's all I did. That's all you need to do. Just don't be scared to take that jump.
So actually, before I move on to some of these, because a lot of these are practical, so we can get onto the practical, but I actually want to ask you more of a philosophical question. So you are obviously going through all of this. I think you started this in grade 11 was your first.
Yes.
Yeah, so you were in grade 11.
Yes.
Okay, a lot of people on the call will be in grade 11, grade 12, grade 10. So you're the age that Saul was when he started doing this, when he did his first trial runs that he was showing you guys. You were also you were doing further studies maths at your school, right?
Yes, I did 9 subjects.
There we go. And further studies physics through Advantage Learn. So your plate was already pretty loaded. And then you added this on top of it. I know you said you didn't sleep much, but there are a lot of people on the call that are taking on these extra subjects as well and are kind of potentially asking themselves the question of how can I keep going? So what is it that kept you going? Where did the drive come from to pile all these things on and to keep pushing forward? How did that work for you?
So I think there was 2 things. The one was passion for learning. One of my favorite
Mm,
things to do is learn anything. I'm currently spending what I'm doing currently, I'm on holiday right now, but I'm spending all day from about 7:15 in the mornings until if it's a Thursday, 1 p.m. No, not p.m. a.m. But if it's other days, it's generally about 11. Just learning all day, just sitting there
mm,
and learning. That's what I'm doing. I enjoy it, to and that's why I just kept saying, yeah, another subject, another subject, another subject. Forgot, exams exist, homework, but ignore that. The subjects helped me hugely in this. The thermoforming, knowing how thermal physics works, kind of
mm,
helps for thermoforming.
mm.
For the designs and how they work, kinematics helped. IT helped. There's so many things that this just came into physical use. And so what I'd say is just follow what you enjoy. I I had to take English. I didn't have the choice. I took English and I did okay at it, but I didn't enjoy it. So after 3 hours of English, I'd be tired and I'd go to sleep. But after 3 hours of something I enjoy, like this, like AP physics, you could just keep going and say, yeah, another lesson, another one. It's to me, if I'm enjoying something, it doesn't take tons of energy to do it. And so just
Mm.
find that thing you enjoy, find your groove. Once you're in it, don't let anything take you in. And and don't destroy your sleep schedule. That was a bad move. Don't do that.
Maybe don't do that part. Maybe you don't need to take on as much as Saul did, but it's helpful to know kind of your thought process there, Saul. And kind of linked to my question is Tuto's question in the chat, which is how did Saul's subject choices help him in his endeavors? So how do
Yeah.
you feel like your subject
So
choices helped you do what you're doing now?
so to understand how the printers worked, and I mean, there's something called uh, there's different types of printers. There's ones which are called Cartesian, which are kind of simple. You have one motor go up, one motor go side, one motor go forward. Those are the more simple ones. You then have a different one, which is actually the one we have, which is it's faster, but it's a lot more complicated. Essentially, you have two motors, and together they do both the X and Y axis, but neither of them does one of them. They both do both. And you have one that does the Z axis. And that was a mind boggle. But if I want to use this machine and, service it and such, maintain it, I'd need to understand it.
Hmm.
And so that became, your equations of motion of x delta x equals this, and this. It suddenly came into it. So IT came in hugely with the machines and how they work and the software side of it. Also things like 3D scanning. It was quite an opportunity, and how that would work came into it. The AP physics came in, things like warping plastic and how exactly it's printing. That came into it hugely. AP maths, I can't say I ever did a derivative to find the curve of one of these of one of these. We did use bottles, and we did have to discuss like what the circumference would have, what the the diameter would have to be to fit a circumference. So that did come into it a bit, I guess. But those, and then biology, fun, because understanding people, to work with people, you've got to understand them. And that was a huge help in understanding anatomy and biophysics.
Mm, so true. And I feel like sometimes taking a subject is less about what the subject is teaching you and more about how the subject is teaching you to think. So I would never discredit that, for those of you who are on the call. Don't discredit your maths and say, I'm never going to use this, It's less, it's not always about what you're learning, it's about how it's teaching you to think. Yeah.
Also, I didn't use the math. That's because the smarter people use them. I just
Love
copied their
that.
way.
Love that. Okay, we've got a lot of questions. So we're gonna have to do like rapid answers for some of these. Okay,
Cool.
so does it melt?
It does at this plastic at 230 degrees. No, not that plastic. This plastic at about 190 degrees, but it will start to deform at about 80 degrees for this one, and like 120-ish for this one.
Amazing. Okay, I'm gonna take a side kind of a side kind of stance and just say that your previous educator, Mr. Hull, is on the call. And he's just popped a message into the chat to say, Saul, you are an amazing inspiration. Very proud to have taught you. So yeah, just
Thank you,
some
sir. I didn't know you were here. Maybe for the
some
bio lesson, sir.
there we go. Lovely. So amazing. Okay. How would a person with an unfunctional hand from the elbow benefit from this?
So so that's where you get into shoulder devices. There's two main benefits. The one would be to, even if it's just a hand that, it's two modes, closed and open. They could put something there, close it, and then they can hold their drink while they do other things, and then just use it like essentially as a cup holder type thing, or an anything holder, I guess. The other one is balance. A thing people don't really realize, I didn't realize until I found out. If you lose an arm, you're severely off balance. If you lose even part of an arm, you get quite off balance. And some people have a prosthetic just to right themselves again. It's quite interesting. Yeah.
Very cool. Things that we don't think about, right, in our day to day. Um, so someone else asks, would it be possible to make the plastic used to print the prosthetic from recycled plastic?
This is one of my favorite questions to answer. So this plastic, the plastic we use for the prosthetics is called PETG, polyethylene tetraphthalate glycol. It is a Coke bottle, water bottle, plastic drink bottles. It's those plus one chemical called glycol. In fact, some bottles are now being made out of PETG instead. There are machines that you can literally print that recycle plastic bottles into filament to be used straight away, that you can, just assemble these at home and start using them. When it comes to color and such, it's a lot harder to then do. But one of the things you can do, and that I know is being done, is you can have these establishments that, the people who make the what's called filament, it's the stuff, the people who make it, if you take your scrap filament and other things like plastic bottles and such to them, they will give you free filament for it, and they'll make filament out of it. And so it's quite a renewable material. This plastic, on the other hand, PLA, it's not recyclable, but it is plant-based, so it is renewable. And waste, we do something called additive manufacturing opposed to subtractive manufacturing. And as a result, we are actually quite a lot less waste because as a result of printing, as opposed to, for example, cutting it out of a block of plastic.
Amazing. Sure. You're very knowledgeable on your subject. It's also very cool that you can
Thank you.
answer on the fly questions. Okay, Monique asks, which skill is required to be able to build objects like these using a 3D printer?
Um, you be able to use a computer, as if you can print something on a normal printer, then you can print something on a Bambu Labs P1P essentially, P1P or XC or XC X carbon X1 carbon space X1C, or the P1S, or the A1 Mini or the A1. Those machines are essentially plug and play. You can print on a printer, you can print on a printer. Not all printers are like this. Creality stuff, you need to be a lot more involved. But if you can figure out, for the printing side of things, if you can figure out how to code or do almost anything engineering-wise, like Meccano, I used to do a lot of when I was growing up, or essentially if you like taking things apart, putting things together, it'll come naturally. And otherwise, it's like 3 articles online, and that's about all you need. When it comes to putting them together, if you ever used Lego as a kid, you're good. These parts come, especially I can't because it's tied in, but this part just slide on and off. Like, it's not difficult. These are just pins that you stick in, take out. They're, like I said, no one's special.
Amazing. Amazing. No, you definitely are special, Saul, just like Mr. Hull says in the chat. But I get your sentiment. I understand what you're trying to say to everyone. We are all special in our own way. So find your problem and figure out how you can solve it, is the key takeaway. There is one more question, which I think relates to earlier you were speaking about obviously being able to print in different materials. And one of the materials you spoke to was metal. So the question is, won't the metal become hot on sunny days?
So it would, and you think this is a problem. But remember, the person doesn't have a limb there. So the metal can be hot. It's okay. When it comes to like lower limb prosthetics, part that touches the person wouldn't be metal. You'd never want that because that would be rough and uncomfortable. We actually took it out because we reused it because we don't like wasting. But there, I sort of can see, I can't see it on camera, but there's glue marks here of the foam. We actually put foam inside of these. Usually, it's the same material that the straps are made of, because it needs to be comfortable. We either use that or a silicone-like substance. Either silicone itself or something, or what I mentioned earlier, TPU. So the metal would never be touching the person, but the metal would otherwise, yeah, get hot on a sunny day, I guess.
Amazing. Yeah, so true. I mean, again, just something that we're thinking about from our perspective, but it's different for the next person.
It's a thing of that's their version of sunburn.
Exactly. So it's just, yeah, it's different perspectives. And so interesting. I'm sure you've had to rethink a lot of this, Saul, as you've come across people with different perspectives. But I think the key takeaway, and I know, Saul, that's something that you mentioned, is there are so many problems out there. This is one realm of problems in the world that people are facing. And so what problems do you notice around you, and what skills can you use, and what people do you have access to that can help you to make a difference? And I'm asking myself the same question. What can I use my skills for to make a difference in the lives of others? And yeah, so you've just been such an inspiration on the call, and
Thank you.
so knowledgeable, honestly. You spoke so well done on that one. I
Thank
know
you.
a lot of you are already part of the program, but there are some people on the call that are not. So if you feel like you already know further studies in and out, and you're on the program, you can hop off. I'm going to take 5 minutes to just break down further studies programs for someone who's interested now in learning more. Like I said before, Saul was a student with us, and he also did further studies maths through his school. So he's very familiar with this world. And so that's the reason why he was on the call, is obviously as a past student of ours. And so if you are interested in also joining our kind of array of students that are part of the program, then stick around and I'm going to explain that. Otherwise, to everyone else, have a lovely evening. Thank you for joining. So like I said to you before, I'm from Advantage Learn. So we do work in a variety of areas, but one of the areas where we support students, and our kind of key reasons for supporting you, is to help you in your future careers. And one of the ways that we do that is via further studies programs. And for those who aren't familiar with further studies programs, essentially you are working for a number of years. That might be 3 or 2 years, depending on the subject that you take. And all of the work that you're doing is really gearing you up towards writing to achieve your final IEB certificate. You are covering first year university level topics in that 2 to 3 year period. And the purpose of that is really to get your mind in the right place to write the further studies exam that's going to get you the IEB certificate. So really importantly, and what a lot of people don't understand, is this is not going to impact your average results on your final matric certificate. This is a separate certificate that you earn. And in order to achieve the separate certificate, you need to achieve above 50% in your final exam. This separate certificate is internationally recognized. So if you are looking to study overseas, that can also be a helpful thing for you. And what's really important here, and kind of what I mentioned when Saul was chatting through the subjects that he took, you can hear from Saul that he took away a little bit from different subjects. And the purpose we feel as an organization behind taking on these different subjects is really not necessarily about the marks. It's really about challenging you, extending you, helping you to grow in a different form of thinking, helping you to think outside of the box, outside of your normal core subjects. And that growth mindset, that grit that you get out of further studies programs is far more important than your result at the end of the day. So that's the key kind of philosophy behind taking on these extra subjects. And there are so many benefits that you can see in taking further studies programs. You will see that you're obviously covering your the subject matter at a much deeper level. So if you're going to take on further studies maths, it's going to help your core maths results, because obviously you're studying maths at a much deeper level, for example. It also is going to help you with university applications, in the sense that you don't have to just submit your matric results. You can also submit additional certificates, and it's just showing the institutions that you've gone the extra mile. So that's helpful. Further studies program, depending on the universities, this subject can count towards your APS score. So it wouldn't be able to replace a core subject like English or mathematics, but it would be able to, in some cases, replace a subject like history. So that's where it can assist from an APS level. If your further studies maths mark, for example, was higher than your history mark, you could ask them to exchange those results so that your APS score is higher. You are less likely to struggle at university. So particularly if you're, for example, taking on further studies physics, and then you're going to go into engineering, you've already covered a lot of those concepts. If you're taking on further studies maths and you end up taking a statistics module in first year, which a lot of people do, even your BCom degrees require you to take basic stats. it's going to help you there because you've already covered a lot of that content ahead of time. It's going to extend you, like I said before, it's going to challenge you, and it's going to give you a certificate that is recognized internationally. So if you are doing really well in maths, then further studies maths is a subject that you can take. What I mean by doing really well in your maths core, is achieving above 75% for mathematics enables you to submit an application with us to enter into further studies maths. If you are achieving above 80% in physics, you can take on further studies physics. And if you are achieving above 65% in English home language, then you can take on further studies English. This is going to help you if you want to prepare yourselves better for university, if you want to enter into competitive degree programs like medicine, where you want to stand out with that extra certificate. And again, if you're looking to study internationally. You can take further studies with us via guided online lessons, live online lessons, and in-person lessons, which I'm not going to go through in detail right now. And then finally, just to share kind of the extra support layers that Advantage Learn offers, when you join our programs, there will be a program coordinator who assists you with any queries that you have. You'll have access to technical support. You will have access to further study support via a class WhatsApp group, and you will have access to our resource bank, so our online campus, where you'll have access to additional further studies resources, as well as a textbook. Every single program comes with a corresponding textbook, which is included in the program costs. So if you would like to apply for these programs in 2025, you can do so by visiting advantagelearn.com, choosing the subject, filling in the application form and submitting your application. And obviously this is application based. We want to make sure that you're in a position to be able to perform well at these subjects. So if you're wondering whether this is a right fit for you, feel free to fill in an application and we can look at your results, and then you can find out, did I get in? Was I accepted or wasn't I accepted? And that will tell you whether you would be able to cope in the program. Okay. I know that was a rush through, but I did want to spend a bit more time on Saul's presentation. So I will send through a recording of a longer form version of further studies information that we've done in video form in the email. So you'll be able to go to that link and find out more information. And I will also include a link to our dedicated further studies information webinar. If you want to attend and join, where I walk through every single one of the subjects in detail so you can learn more about them, I will do that as well in the follow-up email. And I do see that there are a fair number of questions. Let me quickly address some of these. So Maniki, how can we access the recording of this webinar? I will send you an email. It's the email that you use to register for this webinar. And all of the details will be in the email, including the recording of this webinar, including source details, including how you can apply for further studies programs, etc. So all of that will be in there. Perfect. Do we have to pay for further studies programs? Yes, there is a fee attached to further studies programs. Again, I will include all of the details in the follow-up email. So that will all be included there. Okay, another question. If I get a lower mark than, so if you are getting lower marks in the subject than the marks that I mentioned on the call, feel free to leave an application if your mark is close to that range, because we will assess on a case-by-case basis whether you will be accepted into the program or not. So if you're borderline one of those marks and you're just not quite getting as much as the mark that I mentioned, then still feel free to leave an application, and we will let you know if that application is successful or not. And we might give you a call if we want to know more information about other subjects that you're taking and what you're getting in those subjects. Okay, feel free. When do applications close? Applications close next year. However, we do have limited spaces, and we do have lower pricing for earlier applications. So I definitely would recommend, if you know that you want to apply to further studies programs, please apply sooner rather than later. Okay. And that is all the questions, and we are out of time, so just on time. Thank you, Saul, so much again I really, really appreciate it. It was amazing, honestly,
It's an
really
absolute pleasure. Thank you. Thank you,
amazing.
everyone, for tuning in.
And for everybody else who is still on the call, which is actually quite a lot of you, thank you again for attending. And thank you for taking the time. And I hope that you feel as inspired as I do by Saul's amazing story. Thanks, everyone. Have a good evening.